All right. Well, good morning, everybody. Welcome to, what are we on now? Wednesday. Hard to keep track sometimes. We've made it. We are continuing our problem-solving endeavors with a second set from the same section. If you thought we were done, but Mr. Apple, I only need to do level 1. 3 problems is more than enough. No. 3 problems in a week. No. You're not going to get away that easily. We need a few more to go because there's so many good ones in here, so many good things to see and do. But before we get to those new wonderful problems, I would like to go through the answers to the last set of problems and share with you those. And please go through your set, check your work. As you know, I do read through your homework assignments, but I do not check them for accuracy, for points that way. So it is on you to get that comparison and feedback. Say, how did you do? Did you solve this correctly? Okay. Maybe you found a method of solving it that I didn't talk about. That's perfectly valid. Okay. All right. So then, without further ado, here are the answers for problem set 1. How many equilateral triangles of all sizes in this 3 by 3 by 3? 13. 13 total triangles of large, medium, and small. Don't forget the ones that are upside down. Okay. A tetromino. How many tetrominos are there? Right? If flipping and turning. So not just turning. So if you relied on your experience in Tetris, that would give you a slightly larger list. This allows you to flip the pieces over so the Z's become S's and the J's become L's. And so there are only 5 completely unique possible shapes. Next up, question 10. Can you fill in 6 out of 9 squares so that you have none of them lining up horizontally, vertically, or diagonally? Yes, you can. And it relies on this little L shape here because you can never go a full row or column. And notice that the empty ones have to form a diagonal. But that's totally okay. It's just the shaded ones that are not allowed to form a full diagonal. What about if you went to 4 by 4? Yes, indeed, can be done. Here is one possibility, similar kind of based on an L sort of shape, but because it's an even number, we have to do something funky with the middle squares. If you tried to use this same pattern and just extend it and just have all 4 empties in a row, well, there's no single empty square in the middle. This row would become diagonal. I think you can see that, right? If they left those empty, then the other diagonal would all be colored in, and that wouldn't work. So we got to tweak it just a little bit. All right. If you went on to level 2 and tried to find all of the pentominos, all right, made of 5 squares apiece, there are 12 unique pentominos. They're fun to play with. Like, I really wish someone would come out with an actual Tetris 2, and it would be, I guess it wouldn't be Tetris, it would be Pentris. That just doesn't sound right. I don't know, right? But you could go up one, scale it up one more. Use the pentominos instead of the tetrominos. That'd be a cool game. All right. And second, level 2 question. Can you fit 5 different pentominos to fill a 5 by 5 square? Absolutely. Here is one possibility. There are several. Lots of different ways to do this. If anyone has the board game Blockus, or sometimes pronounced Blocus, right? Excellent board game, one of my favorites. This reminds me a lot of that because you actually do have all of the squares, ominoes. And you've got the domino and the triominoes and the tetrominoes all the way up to pentominos. These are the biggest pieces. Trying to fit these on the board is always a struggle. So there, shove 5 of them together in a square. Similarly, you can fit 3 of them into a 3 by 5 rectangle. here is one combination that will work. I don't think it's possible to use this purple one up here, the zigzag, because it literally cuts off a square down there. But if you can manage it, let me know. I'd like to see that. And then finally, tip of the top, level 3 question went on to an hexomino. This now is 6 squares, and the unique thing about 6 squares is that you can form at least some of the hexominos. I don't know if it hasn't been proven that all of them are, but they can be folded up into making a cube. And so a hexomino is actually a net of a cube. So the question is, if you folded these together and created yourself a little Monopoly die there, what number would be across from the 1? So this is a visual spatial reasoning kind of thing. You could, if you had to, actually cut these out, label them, and fold it up, and get yourself a physical prop to answer this. But if you can imagine, let's say C here. Imagine I picked that up and I folded it. And so we start with the face of 1 here, and then attached to it right there is 3. So right over here is 3 as this folds around to the side. Okay. And then the 2 folds down and becomes the top. 2 here. The 4 folds down and becomes the bottom right underneath. Okay. And then that means this 5 has to kick up here, and these seams will need to join in, and so in the back then will be the 5, and then that 6 wraps all the way around the tail side to get over there is the 6. All right, any questions on those problems? Anyone have a super fun and unique solution they want to share? Different possibility, mostly with the coloring in. All right, then let me introduce you to problem set number 2. So here are the level 1 problems you will be starting today, due Friday, so you got 2 whole days to work on it, including all of today's class period. We've got another classic toothpick problem. This one not nearly as esoteric as the intro set with the counting the possible shapes. This is just lay them out. Here's the pattern. Okay, this is the classic type of a toothpick questions. How can I rearrange them to make a new shape? Remove exactly 6 toothpicks and leave 2 squares. 2 squares. How many squares are on here right now? If you say 6, you are wrong. I will let that be the hint to you. Think back to our prior question where we had counting squares. Okay? Size is important here. And B, from the same shape, so reset, go back to this, remove exactly 5 toothpicks and leave 3 squares. 3 squares. And when they say no leftover toothpicks, that means there shouldn't be like a square and then like one of those sticking out. Okay? Every toothpick left on the board needs to be part of a full square. Okay? No implied squares, no like, well, I have almost most of a square here. Like, we're not making a dashed line there. Okay, the only gaps should be at the ends where the toothpicks join up. All right? And again, this is such wonderful questions. I always like to include one of these because at home you can get yourself a box of some toothpicks. Okay? If you don't have any, pick one up from the Dollar Tree, all right? Or some matchsticks. Matches work just as well. And play with this and get some physical props, and you'll get through things a lot faster than if you had to draw and erase with pen and pencil every time. All right, 19. Can you trace the following figure without lifting your pencil and without retracing any lines? If so, describe how. If not, why not? Okay, again, if your answer is no, this is impossible. You have to have a specific reason. What is the issue here that creates the impossibility? Not just, I never could do it, right? We don't know. You need to somehow prove to me that you've either tried every single possibility or you encountered something that there's some feature about it. Hey, there's a rule here. This is how it works, and this thing violates that rule, therefore it won't work. Okay? And if you're describing how, might I suggest, instead of trying to write some paragraph first, draw your line up and then make a right turn, and why don't put a big dot where you start. Okay? Then, as you draw, put in little arrows, like we do with the parallel line symbols, okay, to indicate what direction you are moving your pen in. And then when you go over there, and then we go back this way, so I'm going up that way. Right? So we can kind of follow along your path. Okay? So then you can just kind of draw this, and careful with the intersections, right? When you come to an intersection, right, give yourself some space there. As where if you loop back on itself. All right, what else? Let's go one step further. Let's number these. Right, because I was just thinking, what if you come through from another one, you come back here, you're like, wait, which way did I go first? Okay, so number them. 1, 2, 3, so we know the order in which you went. There we go. That's probably the best, most clear picture you can create. All right, and then finally, number 27. Good old combination type question. A child has 10 blocks with heights of 1, 2, 3, 4, 5, 6. You see where this is going? 7, 8, 9, 10. Okay, one of every height. The child wants to use only these 10 blocks to build 2 separate towers that are exactly the same height. Can it be done? If so, how? If not, why not? Right? So we're saying if you take the 1 block, and then you take the 2 block, and then you take the 3 block, right? Here I've got 2 towers, both 3 blocks high, right? Except I've only used 3 of the blocks. Can you use all the blocks? Right? All of them. It says only these 3 blocks, but it should also be in all the blocks. Because otherwise I'm done. I've got the simplest possible result there. But this will give you an idea of what we're aiming for. Find a way, 2 different ways to make the same combination out of these numbers. All right, any initial questions, confusion on these problems, what they're asking for? Okay, my hope here is to lay the groundwork for that step 1. Make sure you understand the problem fully. And now it'll be on you to start devising your best plan going forward. And if you're done with these, go on to the level 2 ones, all right? I didn't include them on my page yet. They are still there and available. They're also very good problems, good questions. Number 3, as usual, or the level 3 one, phenomenal problem, classic math puzzler. Otherwise, you have the rest of the period to work. Have at it.